Hello guys, and welcome back to my video series on integration. Now this is the fifth chapter, the fifth section in this playlist on integration. So in this chapter we are going to be looking at integration by algebraic substitution. Okay, now most of the questions I'll be solving here, they are questions we've already solved in I think that should be the second and the third chapter, or the second and third section, where we discussed about forms of integration, the one that deals with fraction and the one that deals with multiplication. But yeah, I'll be showing you a different method you can use to solve them. So this comes in handy when you're confused or you can't remember the formula that you're meant to use that we treated in section 2 and 3. You can go ahead and check section 2 and 3. I think I'll put a link in the description below. Okay, go ahead and study those parts if you haven't. So when you can't remember those formulas, then this is very handy. It's a procedure, it's not a formula. This is a procedure you have to follow. So it's a method, and for some persons, understanding methods or trying to do things with method is quite simple for them compared to trying to remember a formula. So to better understand how integration by algebraic substitution works, we have different kinds of substitution. We have algebraic, we have trigonometric substitution, we have hyperbolic substitution also. But for you to understand how the algebraic substitution works, I think we should just go through some examples, then you see how we take care of this. So you have this as the first example. You have the integral of 6x all over x squared plus 4, and then you're asked to integrate this. Okay, so now for you to integrate this, you have to make a little bit of substitution. You have to pick the denominator and equate the denominator to be something that's what you're going to use to work with. So usually what we do is this. Let's see. This time around I think I'm going to use a white color marker or white color. I noticed the red is somehow fainted for. So let's see. We have to say, we make a substitution, something like okay, let the value of u, let u be equal to the denominator, which is usually the denominator but not always the denominator, just usually. So this should be equal to x squared plus 4. That's the denominator. Now you have to differentiate this denominator and see what you're going to get. So let me just divide this into 2, and hopefully I'll be able to conserve that. So if I differentiate this denominator, I'll differentiate u. In this case, I'll differentiate it with respect to x. Okay, so if I differentiate u with respect to x, differentiate x squared, what you're going to get is 2x. So you have 2x. Now you cross multiply, you're going to have du equal to 2x dx. Right? Now while you cross multiplying, what we want to do here, we want to see if we can make dx the surrogate of the formula. So if du is equal to 2x dx, then for you to make dx formula, you divide both sides by 2x. So dividing both sides by 2x, you have dx to be equal to du all over 2x. So this becomes the value of dx. So now wherever you see dx, you're going to put du over 2x, and wherever you see x squared plus 4, you're going to put u. So this expression as a whole, it's now going to be the integral. 6x remains 6x. We've not done anything to that. But instead of x squared plus 4, what we have now is u. In place of dx, we have du over 2x. So here we are going to put du over 2x. Now from what we have here, this and this will cancel. X will cancel x. 2 will go into this to give us 3. So we have the integral of 3 all over u du. Okay, so now 3 is a constant. We can decide to factor out 3, and we have the integral of 1 over u du. That's what we have. So this is going to give us 3. If you integrate 1 over u with respect to u, what you're going to get is the log of u, so which we usually write as ln u. So as usual, you're going to have your constant plus c. Now if you don't want to write this as ln u, okay, you can still leave it like this, but for the sake of multi-choice questions, this can also be expressed as ln. Transfer 3 to this side, becomes the power. You have u raised to the power of 3 plus c. Okay, and if you still want to take this a step further, instead of ln u, you can have it as log of u cube. Most times they will give you see log of base 3, but it's log of u cube then plus a c, and that's basically the result you have for this. Okay, so you can see what we did was to make use of the denominator. It may not always be the denominator. It will not always be the denominator. I'm going to solve questions where you won't have the denominator, but it's still going to be the same process. Okay, so let's see another example. This time around we have this expression 2x squared plus 8 all over x cubed plus 2x. So same thing, we are going to work with the denominator. So here we say let's the denominator be equal to u. We love using u, that doesn't mean it's always also going to be u, but yeah, let's say it is x cubed plus 2x, right? So that's what we have. So we need to differentiate this. Same thing, let me divide this part. So if I differentiate this, I'll have the u all over dx to be equal to, differentiating will give me 3x squared, and differentiate 2x, you're going to get your result as 2. So you cross multiply, du is going to give us this I should put in brackets for the sake of the fact that we have more than one term there. So I have this, I'm cross multiplying, so that's going to be multiplied by dx, right? So you want to make dx or a formula, take note. So you divide both sides by 3x squared plus 2. Dividing both sides by 3x squared plus 2 is going to give you dx to be equal to, I think I need to wipe that now. Okay. So it's going to give you dx to be equal to, this should be du all over 3x squared plus 2. So we have 3x squared plus 2. So this is what we are going to be substituting into this expression. So let's substitute. So we are going to get the integral. This remains 12x squared plus 8. But now we are dividing by, everything we have as denominator now is u. Then we are multiplying by dx, but in place of dx now is du all over 3x squared plus 2, right? Now if you notice this, the numerator have something common. I think 4 is common, so if you can factor out 4 from the numerator, if I factor out 4, here I'll be left with 3x squared plus 2 divided by u times du all over 3x squared plus 2. So you can guess by now that 3x squared plus 2 will cancel out 3x squared plus 2. What we have now is 4, the integral of 1 over u times du. Okay, so integrating 1 over u will give us ln u. So our result here becomes 4 times of ln u plus c. So like I did in the previous example, you can take this 4 to the top to become the power of u. You can transform it from ln down to the log to base e or just log, and that is going to be the solution to this example. Okay, so they are quite simple. You can see these two, we didn't waste much time in solving them. Let's see the next one. Now we have the integral of tan x dx. Now if you integrate tan x, the first thing you need to do is to transform this. I wonder why I brought this to the side. So when you transform this is going to be the same thing as sine x all over x. So now we have a fraction, we have a denominator. So our best guess is, let's take the denominator. So I'm just wipe this, let this guy be this part. So I'll just take the denominator and equate the denominator to be u. So we say let u be the denominator being cos x. So cos x should be the value of u. Now since cos x is the value of u, we can go ahead and differentiate u with respect to x. If we differentiate u with respect to x, our result will be minus of sine x. That's what we have, minus of sine x. So now we need to make the I'm differentiating with respect to x. So we need to make the x a formula. We cross multiply, starting with that. So if we cross multiply, we have du equal to minus of sine x dx. That's what we have. Dx. What's wrong? So minus of sine x dx. That's what we have du as. So from there we can divide both sides by minus of sine x. So if I divide both sides by minus of sine x, I'm going to get the x to now be equal to minus of du all divided by that should be divided by sine x. So now anywhere I see the x, I'm going to put minus du all over sine x, and then in place of cos x, my expression is going to be u. So I'll do that in this expression. If I do that now, my solution is going to be the integral. Sine x remains sine x, obviously. Sine x remains sine x. In place of cos x, what I have now is u, times in place of dx. Dx is now giving us the result as minus du all over sine x. Okay, that's what we have, all over sine x. So now sine x will cancel out sine x. What we are going to be having there is minus the integral of du all over u. So this u, more like I'm integrating 1 over u with respect to u. So if I integrate 1 over u with respect to u, my result will still be ln u, but remember there's a minus sign outside. So what I should be having, please ignore this, what I should be having there should be minus of ln of u, then plus c. This becomes my result. But we can take these steps further, like we've been doing in other cases. Take the minus sign to come to the top. So I have ln of u raised to the power of minus 1. Then we have plus c, right? Which can also be expressed as ln of 1 over u. Then we have a plus c. And that is the solution to this. Is the last question, okay? And that's how you solve using integration by substitution. Okay, so in the next video, I'm going to be showing us a couple of more examples you can solve, but these ones are all involving fractions. What if it does not involve fraction? How do you go about solving it? So that's what we are going to be looking at in the next video. Okay, so go ahead and practice these questions, practice other questions. If you have issues, you can chat me up, you can try to contact me, and as usual guys, I'll see you guys in the next video. Bye bye.